What is inverse fast Fourier transform, IFFT? Imagine you have a puzzle made of many tiny pieces, and these pieces are the different frequencies that make up a signal. Now, what if you wanted to put those pieces back together to see the original picture? That's where the inverse fast Fourier transform comes in. It is a special math tool used in electrical engineering to turn frequency data back into a time-based signal. When engineers analyze signals, they often use the fast Fourier transform, or IFFT, to break a signal into its basic frequency parts. This helps in understanding what frequencies are present and how strong they are. But sometimes, after processing or filtering these frequencies, you need to rebuild the original signal. That's what the inverse fast Fourier transform does. It takes the complex numbers that describe each frequency's amplitude and phase and puts them back into a time sequence. The word fast in the name means this process is very efficient. It reduces the amount of calculations needed compared to older methods. Instead of doing many complex calculations, the algorithm simplifies the process, making it quick and practical for real-time systems. The main benefit is that it can handle large amounts of data without taking too much time. In digital signal processing and control systems, the inverse fast Fourier transform is used a lot. For example, in wireless communication, signals are often processed in the frequency domain to remove noise or improve quality. Once the processing is done, the IFFT converts the data back to the time domain so it can be sent or played back. It is also used in audio processing, image compression, and even in radar systems to reconstruct signals after analysis. Most software tools like MATLAB have built-in functions for the inverse fast Fourier transform. When you run this function, it takes your frequency data and returns a sequence of numbers that representing the original signal over time. This process is lossless when used correctly, meaning if you do an IFFT followed by an IFFT, you get back your original data exactly, assuming no numerical errors. In summary, the inverse fast Fourier transform is a quick and reliable way to turn frequency information into a time-based signal. It helps engineers analyze, modify, and reconstruct signals in many modern electrical systems. Whether in communication, audio, or control systems, the IFFT is a key tool for working with signals in the digital world.